Hello friends, welcome back. Today we are going to start new chapter, that is chapter number 2, circle. Now in this chapter is a little bit long chapter. Okay. Now in this chapter many theorems are there. I am not going to take the proofs of the theorems because those proofs of the theorems can be directly read from the book. Okay. Many students by heart the theorems. But that is not the problems of the student. Real problem of the student is how to solve the problems based on the theorems. That means which theorem is to applied when. Because whenever we are solving the chapter in the series like 2.1, 2.2, 2.3, so you know that 2.1 is based on 1, 2 and 3 theorem. 2.2 is based on 3, 4, 5 theorem, something like that. So solving this is easy, okay, but in exam the problems are at random. So at that point, if in the circle there are 10 to 15 theorems are there or the properties are there, then students don't understand when we should use which property or when we should use which theorem. That is the main problem. So in this chapter, our approach of solving the problems or understanding the chapter will be something different. This technique or this process is called as the reversed engineering. Reversed engineering means, suppose there is one instrument is made by India or Japan. Okay, whenever somebody copies it, what they do? They disassemble it completely, take a smaller parts, assemble it again, and then they make a prototype. This is called as the reverse engineering. This approach is totally different. First of all, you have to decide how can we solve this problem and then go back from the answer. We will not start at the vague and then go to the answer. We will first decide how we will get the answer, and to get the answer we will come back towards the starting of the problem. This is called as the reversed engineering. So we will approach the problems or the theorems in such a way that any problems comes in your way. Now for example, even 30, 60, 90 triangles are there. Even that property also you can use here. That means that use of trigonometry also can be done in the circle. Okay, here they call as the 30, 60, 90 properties, but that is nothing but a trigonometry. Okay, and in exam they don't tell you that don't use trigonometry or don't use that, don't use this. So while solving the problems in this chapter, in the circle chapter, you will require the help of properties and theorems in this chapter, but also the congruency or similarity properties or parallelogram properties from the past years or the past chapters. So only the knowledge of circle is not enough to solve the problems in this chapter. So we will keep our eye on the problems itself rather than the theorems. I will explain the theorem, okay, but I am not going to deep into the proof of the theorem because hardly you will get the proof of the theorem in your exam. Sometimes it get, sometimes it won't. But the main important is the problems based on this chapter. This chapter number 2, circle, and a similarity. These both the chapters are the lengthier chapters. So let us start this chapter. We'll solve all the exercises in this chapter. We'll see all the theorems and properties, and basically we will decide our approach to solve the problems in this chapter. Okay. Now first of all, in the previous chapters also, if you are gone through my algebra lectures or the science lectures, then every time I tell you that don't only rely on what you are going to learn now. You should know whatever you have learned in the past about this particular topic. For example, in the circle we are going to deal with the properties, tangents and other properties of the circle, arcs and secants and all those things. But don't forget the basic properties you know about the circle. For example, radius, diameter, area. Area is not required here, but still you should know that. You should know the Pythagoras theorem, how to apply it. All these things are required to solve the problems in this chapter. The first part of this chapter, that is we will see the topic 1, that is related to tangent. Okay, now what is the tangent? What do you mean by the tangent? If there is a circle and if any line is intersecting that circle, now you know, if this is the circle, and this is the line intersecting the circle, it will intersect the circle in 2 points, correct? But suppose any line is there which is intersecting the circle in only 1 point at its external edge on the circumference, only 1 point, it is intersecting only in 1 point, then this line will be called as tangent to the circle. In short, this line generally just touch the circle, but we call it as intersecting that particular circle in 1 point. So at this particular point there can be only one tangent. Okay, now this is the tangent. You know what tangent is, that you know. Now let us see some of the properties of the tangent. Okay, we are going to learn 2 main properties of the tangent. The first is this is center O and this is radius. Our first property is the tangent and radius at that point, at the point of contact, are always perpendicular at a 90 degrees. That means radius at the point of contact to the tangent is perpendicular, and vice versa is also true. If any line is perpendicular to radius at the point of contact, then that line is tangent to the circle. This is the first property we are learning here. This is the first theorem we are learning here. Okay, so we have learned 2 things. The first, this tangent is perpendicular to the radius at the point of contact, and converse, if this line is perpendicular to radius at the outer side of the circle, then this line is tangent to the circle. That means if you want to prove that if this line is tangent to circle or not, then you have to just prove that this is right angle. If you can prove this is right angle, then this line is obviously tangent to the circle. Okay, so if you want to prove this is a 90 degree, then you have to prove that this is tangent to the circle and this is the radius, and by the theorem it has to be 90 degrees. Okay, another thing we are going to learn, that is the tangent segments. In the construction, you know that the tangent segments, what are the tangent segments that you know? Suppose there is one circle, okay, and there are 2 tangents which are intersecting at any external point P. Don't look at my figures. My figures are not very perfect because I am drawing by hand. These 2 are the tangents. This is the point of contact. This is the A and this is the B. Then AP and BP are called as tangent segments. AP and BP are called as tangent segments. Now the theorem is like that. These 2 tangent segments are always congruent, are of same length, are congruent. This is the third thing we are going to learn, or we are learning in this chapter, that is the tangent segments meeting at the point external to the circle are of equal length. Now we have learned 3 things. Tangent is right angle to the radius at that particular point. We have learned that tangent segments are equal, and we have learned that there can be only one tangent at a particular point on the circle. Okay, now if this is the figure, what extra thing, always think what extra knowledge you have about this figure. Okay, now you know that these 2 are the tangents, so these are the tangent segments. Since they are meeting outside the circle at a particular point, So BP and AP are tangent segments. So you know that these two are congruent. These two are equal. What else may not be shown in this figure, but what else you know? You know that OB is a radius, also OA is a radius, and these are 90 degrees. This also you know. Okay. Now from this figure, what else you can predict or what else you can say? For example, if you connect OP, then what will happen? This is right angle, this is right angle, this is radius, and this is the common, or even these two sides are equal. So by SAS test, both the triangles are congruent triangles. This also you can prove. Okay, that means these two angles are also congruent angles. They are not given it. We are going a step by step advance. Okay, so only one figure was given, but we have constructed one more line, and then as per our basic knowledge or previous knowledge, we say that these two angles are 90 degrees, these two segments are congruent, these two are the radius, must be of the same size. So by SAS property, these two triangles can be shown congruent, and if they are congruent, then this angle is also equal to this angle. Okay, so whatever figure you are given, you should always think that what else I know in this particular figure. Okay, or what else, if I draw some parallel lines or if I connect some points, can I prove something different? Can I prove something else? That you have to think and you have to find out in every figure. So now based on these three, let us see a few examples and then we will go to exercise 2.1. Let us see one example. They are given one circle. And there are two tangent segments. This is the problem they are given, and they are asked to find out this angle. They are asked us to find out this angle. Okay. Now before starting this problem, before starting solving this problem, first let us understand what this figure is and what we know about this figure. Maybe sometimes that knowledge is not useful to solve that particular problem, or that is not required, but it's a habit. What we can see in this figure, these two are the tangent segments. So I know that these two are congruent. I know that. Okay, I know that this is the tangent and this is the radius, so these both the angles are 90 degrees. Correct? This much I know. I want to find out this angle. Now can you say this is a quadrilateral AOBP? AOBP is a quadrilateral. Correct? And we know that the addition of all the angles of a quadrilateral is 360 degrees. So now one more thing I want to tell you. Whenever such quadrilateral or triangles etc., there are so many angles are involved, generally in books, in your digest or in your notes, always the angles are given. Angle AOB equal to, angle PAO equal to angle OBP, but after some time it gets confusing. While writing also you may commit mistake. So as far as possible, give names to those particular angles, so it is very easy to solve. So I will name this angle as X, I will name this angle as Y. You can name any angle, give names in the small letters, or if one angle is there, write theta. So now I can say that in quadrilateral AOBP, you have to write this, in quadrilateral AOBP, X plus Y plus 90 plus 90 is equal to 360. Correct? So I got X plus Y is equal to 180. So X plus Y is 180. But can you say this is a linear pair? So this is first equation I got, and this is the second equation I got. Y plus 130 is equal to also 180. Isn't it? Simple. So now y is equal to 50. 180 minus 130 is 50. You can substitute here. So if y is 30, x is equal to 130 degrees. Correct? But now if you want to solve by the traditional method, what you have to write? Angle AOB plus angle APB plus angle OAP plus angle OBP equal to 360. And since you have to give reasons, initially you have to give reason. This angle is 90 degrees because radius and tangent. Angle between radius and tangent at that point is 90 degrees. And then you have to solve. But here it is very easy to solve, easy to write also, and easy to understand also, because this problem is quite easy. But later on, when complicated problem comes, then it is a real problem to write the names of the angles. Okay, so this was very simple problem. Let us go ahead. In this problem, what they are given? One circle is given. These are two tangents. So TP and TQ are two tangent segments. Okay, O is the center of the circle. Now they are given this line PQ, and what they are asked? They have asked to prove that this angle is equal to twice of this angle. Now this figure is complicated, little bit complicated. Let us see what they have asked. Prove that angle PTQ is equal to twice the angle OPQ. Twice the angle OPQ. PTQ is equal to twice the angle OPQ. Now in this case, when we want to prove, if you write all these things in this format, after some steps, 90% of the students will lose the reference. Okay, they will confuse themselves within the angles. So my suggestion here is always give names to the angles. If you give names to the angles, then it will be very easy for you to solve the problem. Okay, now before going ahead, let us examine the figure and we will find out what we know about this figure. Okay, first I know that this side equal to this side because tangent segments are always equal in measure. I know that since this is tangent and this is radius, this is 90 degrees, also this is 90 degrees. Fine. I also know that this T, P and Q, this triangle is isosceles triangle because two sides are equal. So corresponding angles, opposite angles to the both the sides are also equal. So this angle is equal to this angle. What I have to prove? Now I will name the angles. I will name this angle as let us say theta. I will say this is X angle. So this is also X and this angle is angle Y. Later on, if you want to give the names to angle and solve, you can do that. But for understanding, let us give names to those angles. Now, can you see in this triangle, Q plus 2x equal to 180 degrees because addition of all angles in the triangle. Here I am not writing the reason and all those things, I am leaving it to you. But before writing everything, you should give the reason. After writing, you should give reason ahead, or first give reason and then write the statement. So my statement here is theta plus 2x is equal to 180. This is the first equation I got. Correct? What I have to prove? I have to prove that theta is equal to 2y. What second equation I can say? Since this is 90 degree and x and y are the linear pair. X and y are linear pair. So x plus y is equal to 90 degrees. This is the second I got. I want in only theta and y. So I will substitute x here. So what is my x? X is equal to 90 minus y. Correct? I will substitute it here. So from 1 and 2 I can say theta plus twice 90 minus y is equal to 180, and hence theta plus 180 minus 2y is equal to 180. This 180 will get cancelled, and I will get here theta is equal to 2y. Simple. Now for your exercise or for your practice, you solve same problem but not taking the letters for the angles. You give the proper names to angle, and then you will come to know how complicated it is to write. This is also valid. Okay, you can initially write one statement that let us give the names to the angle theta, x and y as shown in the figure. You have to draw the figure. Every time in this chapter you have to draw figures, circles. Don't go for the compass and draw the circles. Okay, either you take a small bangle or you can take the pro circle where different size of circles are there, but we want somewhat bigger circle also and some smaller circles also. So I will not suggest at all to draw these circles by compass, because these are the rough figures. You have to just imagine those figures. Okay, not necessary, these figures are not to the scale. So draw this circle in the rough by pro circle or with the help of bangle. Okay, but be sure that these lines are proper touching. Use proper scale and draw figure little bit bigger. Okay, so that there won't be this x and y etc. won't be very much congested. So just take care in this, and pause your video right now here and solve this problem again by not giving the names to the angles. So what you have to write in this case, that theta, that means angle PTQ plus twice the angle TPQ is equal to 180. Initially you have to write that this plus this angle plus this angle plus this angle is equal to 180, then these linear pair and all those things. So you will come to know the importance of giving names to angles. Okay, so please pause your video and solve this problem again by giving names to the angles. Now let us solve one more problem. The figure is given something like this. There is one circle, there are two tangents meeting at the point T outside the circle, then there is a center O, and P and Q are the touching points. That means TP and TQ are the tangent segments. Correct? They are given that the radius of the circle OP is 5 centimeters, and they have connected these touching points PQ. One chord is there, and they are given this side PR is 4. Okay. Now they have asked us to find the length of the PT, that is the tangent segment. Length of the tangent segment we have to find. Now how will we proceed? The first thing first. First we will see what we know in this case. We know that this side equal to this side because of the radius. We know that this side equal to this side because tangent segments are equal in length. What else we know? We know that this is right angle because radius and tangent at the touching point are perpendicular to each other. What else we know in this case? That's all. Fine. Now how will you find this PT? In case if we can prove that these two triangles are similar, that is PRT and this smaller triangle, upper smaller triangle, if those are similar triangles, then we can make use of the ratio properties. In these two bigger triangles, can you see that side angle side? Side angle side SAS property can be used, and we can easily prove that these two triangles, this bigger OPT and OTQ, they can be proved easily as a congruent triangles. Correct? So these are the radius of the circle, these are the tangent segment and this is right angle. SAS property, we can easily prove that these two triangles are congruent and hence these two angles are congruent, corresponding angles of congruent triangles. Correct? Now leave upper part apart. Now this triangle PRT, let cut the upper part. Now in these two triangles, angles are equal, okay, and this side is common, hypotenuse is common. So now in these two triangles PRT and RTQ, these two triangles, we know that this is the common side RT, this is the common side, this angle is congruent and these two sides are equal. By SAS test, we can say that these two triangles are congruent triangles and hence PR is equal to RQ. So if PR is 4, RQ will also be equal to 4. If PR is 4, then RQ is also equal to be 4. Corresponding sides of congruent triangles. Correct? But can you see that? This is the RA has become now the midpoint. R is the midpoint of this chord. And we know that the line joining the center of circle and midpoint of chord is always right angle to each other. That means this is right angle. Correct? Simple. So now you have got two right angles. One small right angle and one bigger right angle. Correct? Now, in this small triangle, can you easily find the OR? Very easy. By Pythagoras theorem, because this is right angle triangle, 5 square minus 4 square is this square. Correct? That means OR will be equal to 5 square under root minus 4 square. That is 25 minus 16, that is 9. So OR is 3. So this side we have got 3. Now this is also right angle triangle. This is also, PRT is also right angle triangle. Correct? And two right angle triangles are always similar triangles. So now we have found out this is 3. Now we have got two right angle triangles. The first is this smaller one and second is this bigger one, OPT. If we want to prove that these two angles are similar, then we want at least two angles to be congruent. Let us see, right angle we have, one right angle we have, here also right angle is there, here also right angle is there. Can we say that some other angle is congruent? Let us find it out. This is right angle, means this angle plus this angle, two internal angle, is equal to 90 degrees. Now in this bigger triangle, this is 90, so this O angle plus T angle is equal to 90 degrees. Correct? But this is common. So this angle T is congruent to this angle. Again I am telling you, we have the dimensions of this 5, 3, 4. So if we can prove this small triangle and this big triangle are similar triangle, then we can easily find out the PT by ratio. Correct? So how to prove the similar triangles? We need at least two angles. So by AA test, similarity can be proved. One angle is there, right angle. So more one angle must be congruent. Can we say that here in this smaller triangle, this is 90 degrees base angle. So this angle plus angle O. Now forget about right side of the figure. I'll just call this as angle O. Okay. This angle plus O is equal to 90 degrees. And in this bigger triangle, this angle T plus angle O is equal to 90 degrees because this is 90 degrees. Let me elaborate this more easily. Let us call this angle as X, this angle as Y, and this angle as A. So X plus A is equal to 90 and Y plus A is also equal to 90. Can I equate both? If I take, instead of this 90, if I take y plus a, then I don't want this. I will just eliminate a. So x is equal to y. So angle y is equal to angle x. Here we can now prove that by a test of similarity, these two triangles are similar. Two right angle triangles we have. Correct? Now the hitch is in writing the names of those two triangles. Okay? This is the base and this is the shorter side. I'll write ORP. Now the name of this smaller triangle are written ORP. You have to take the similar vertices of this triangle. Similar vertices you have to take, because now both the right angle triangles are there. So here I have taken base and the shorter point. So here will I have take R as a right angle. Now P, R and T. I will write triangle P, R, T. These two triangles are similar triangles now. So now you just take the ratios. What I want to find out PT. So if I take PT upon, if I take PR, PT upon PR, so what I should take? OP, PT upon PR, so OP upon OR. So PT I have to find out. So PT is equal to, what is OP? Is 5. What is OR? Is 3. And into PR, what is PR? Is 4. Simple. So what is the PT now? PT is equal to 20 upon 3 centimeters. Of course you can further simplify it. 6.666. Is it clear? The only problem you will face in this is how to write the names, because once the properly name of the triangles are written, then taking the ratio is very easy. Because here I have taken PT upon OR, first and third upon first and second. So here also I will take first and third upon first and second point. So if you wrongly write the similar triangle names, then even this will also be wrong. So again I am telling you, I have taken these two triangles, this smaller triangle and now this PRT triangle. Okay, how I started writing the names? I am not taking the right angle here. Okay, I have taken the just point above the right angle, that is ORP. So now this triangle is like this. This is the right angle, and now I am taking the shorter side, because here also I have taken the shorter side. So hypotenuse I will not take. So this is the right angle, so I will take the point above it, PRT. Okay. Now once the names of the similar triangles are written properly, then the taking ratio is a very simple thing. So this is how any problem is to be solved. Okay. First of all, understand what we want to find out and understand how can we find out that. That means in this figure only these two dimensions were given. So I say if I can prove these two triangles similar, then I can easily find out the ratio, and by ratio I can find out the PT. But to make two triangles similar, I need minimum two angles similar, congruent. Okay, so how will I prove the angles congruent? So I went through the process. First I found out this, then this is right angle, then I proved these two angles are equal, and so on. Again, let us explain this figure. We want to find out the PT. So my first step was, I took two triangles, bigger triangles, full triangles, and say tangent segments are common, radius are same, and both these angles are 90 degrees. So by SAS test, these two triangles, these two bigger triangles are congruent, and hence these two angles are congruent. Okay, this is my first step I found out. Now I took the smaller triangles. Just forget about the upper part of it. Correct? Now in these two triangles, these are the tangent segments, this is the common side, and these two angles are congruent. So by SAS test, these two triangles are congruent, and so these two sides are equal, corresponding sides of congruent triangles. Now this is the midpoint. It has suddenly become the midpoint. Okay, so any line joining midpoint of chord and center is perpendicular. So now I got this is perpendicular, this I got right angle, and since this is right angle, I know two sides. By Pythagoras theorem, I can easily find third side. So now I can see the figure in better perspectives. Like I have this smaller triangle and this bigger triangle, and these two triangles now can be easily proved as similar triangle by AA test. How? In the smaller triangle, these two angles are 90. In this right angle triangle, these two angles are 90. Correct? These two angles are 90. A is common. So y is equal to x. Correct? Now I have taken this triangle and upper smaller triangle and proved that those are the similar triangle because AA test of similarity, and then write the names of the triangles properly of the similar triangles and find out the ratio. So this is how generally problems are to be solved. Okay, so I first decided how will I find out the answer and then went in the reverse way. Okay, otherwise how will you come to know how to start, where to start, and which property to use? Now here, whatever we have learned, we have used only one property or two properties. This is the right angle and these are the tangent segments. All other things are from the different chapters. So you will be confused where to use which rule. So always go in the reverse direction. Correct? So now let us go for the exercise 2.1. Thank you.